Hello. Yeah, in this video, I want to show you yet another R package for variable clustering. It is called the ClustofVar package. Okay, and so let's check if it's installed. It is. So loading the library and also loading mass library to generate a simulated data set, random seed, sample size. The main strength of this package, ClustofVar, is that it can do variable clustering for both continuous and categorical variables. That is, it can cluster mixed data. Okay. So I'm going to generate two categorical variables, one and two. And then I want to create a correlated continuous variables. First, define a correlation matrix. So you can see the correlation between variable 1 and 2 is 0.8, between variable 1 and 3 is 0.5, and between variable 1 and 4 is 0.3. Okay, so and then we generate these continuous variables from the multivariate normal distribution. And also, we want to build in some correlation between the continuous variables and the categorical variables. So we use this if-else statement, just changed a little bit about the continuous variables. So here, um, continuous variable 1 is related to categorical variable 1, and continuous variable 2 also related to categorical variable 1. Continuous variable 3 and continuous variable 4 are related to categorical variable 2. Okay. All right, so then we put all these variables together, and this is the first couple of rows of this data set. We have 4 continuous variables and 2 categorical variables. And there are correlations between the continuous variables, and there are correlations between categorical variable and continuous variable. Okay. So in order to use the R package, ClustofVar, first we need to separate the data set into numerical data and categorical data. So the numerical data is really the data with continuous variables. Categorical data are the data with categorical variables. Okay. And you can see the function is hClustofVar, and the syntax is x dot quanti. So this is the quantitative, so equal to new number. So this is numerical data. And then x dot quali, so the qualitative variables equal to the cat underscore data. So those are the categorical variables. So you have to feed the data into hClustofVar by dividing the variables into quantitative and qualitative variables. Okay. And then once you've done the clustering, you can plot it out, the dendrogram. On the right, it looks like, first the title is a dendrogram of variable clustering correlated mixed data. Okay. And you can see categorical 1, continuous 2, they look like in one cluster, and then category 3, category 2. Oh no, continuous 3 and category 2 seems to be in one cluster, and continuous 4 seems to be by itself. Okay. And this is what this clustering, hierarchical clustering method leads to. Okay. And if you want to get the memberships, for example, we just choose 3 clusters and just use the cut tree var function here. And then we can print out the cluster membership, look like that. So you may wonder what the squared loading and correlation means. So the squared loading indicate how much the variable's variance explained by the cluster. So the higher, the better. It represents the importance of the variable within the cluster. Okay. And the correlation is the measures the strength and direction of the relationship between the variable and the synthetic variable or the centroid representing the cluster. Okay. And their relationship is the square loading equal to the square of correlation. Okay. So you can see the correlation can be negative. Okay. But the squared loading is always positive. And there's no correlation for the categorical variables there. Okay. So for example, for cluster one, the continuous variable one is very important for this cluster. And so is the continuous variable two and also the categorical variable one. Okay. So they look like this clustering is, all these variables contribute to the clustering a lot. And the last one is this cluster 3 only contains one variable, which is continuous 4. Okay. All right. This is a very brief video just showing you how to use this package ClustofVar for variable clustering. And of course, we didn't go further for any post hoc analysis after the cluster analysis, such as assessing the stability of the clusters and describe the cluster profiles, etc., etc. Okay. But yeah, now we have several R packages we can use for variable clustering. Thank you. Yeah.